Hi there, my name's Chris and I'd like to go through how to make a web server in Chicken. I'd like to focus on the workflow and how we get there, not so much the resulting code. And I'd like to, I'm assuming that you already know a little bit of Scheme and perhaps have touched upon Emacs a couple of times. We're going to show a REPL in Emacs and how powerful that might be. And we're going to be doing part editing, and hopefully you'll find this useful. So I'm assuming that you already have a Chicken installed so that you can do things like this, CSI, and add numbers, for example. I'd also like to show you another program that's I'm a big fan of. It's called Cat, and if you haven't used this before, it's the very simplest thing where it just echoes back what it reads in. The reason I'm showing you this is that I'd like to show you this in Emacs. Let's start Emacs. I'm going to run the command run scheme, but I'm going to do it with a prefix so that it asks me which program I get to use for my interpreter. I'm going to pick cat here, just so that we start off with the very basic to see and understand how Emacs and the REPL buffer integration actually works. As we know, it just echoes this out, so whatever I put in here is going to come back to me from the cat program. Let's open a scheme file. Testing.scheme. So, print hello world. I can do this here, obviously, and it just pops it back, and this would be centered. So I can use my scheme interpreter on the right-hand side, my buffer on the right-hand side, like I did in my terminal here. But I can also send stuff from other scheme buffers into the REPL, and this is where things start to get really useful. If I press Ctrl X, Ctrl E here, this gets sent to my buffer. As you can see, cat is printing out what Emacs sent to it. And I can do define top level function without any arguments, and I can press Ctrl X, Ctrl Meta X, and it picks out this. So wherever my cursor is, it's going to pick out that body definition, the function body definition. And the reason it's doing that is because it's looking for whichever line is not indented. So it's relatively simple the way it picks up this, and it just picks up that X expression there. So let's do this with a real interpreter. CSI will do. So now, if I do this now, top level function, I'm doing Ctrl X, Ctrl E here, and it's running that. If I put it just the cursor one to the left, I'm actually evaluating the name of the procedure, as if I'd done this. And that's very handy as well, I find, because it tells you the arguments that are expected for that function. Another thing that can be useful is evaluating code that's inside comments. I do this quite a bit. For example, we can show example usage for this function. So let's have an argument, add an argument, and we add one to it. So now we can say, obviously this is just for documentation purposes, top level function 12. If I do this now, I forgot to reevaluate it. This happens sometimes. So redefined 13. So even though it's in a comment, I can have Emacs send it to my scheme interpreter. This is useful sometimes. All right, let's actually write something useful. So from spiffy 18, we've got start thread. Thread. It takes in, thread start it's called. Thread start. It takes in a thread or a lambda. Hello world. If I run this, it's going to run this, but it's running it in a separate thread. It's also returning the thread to me. So in my REPL session, this is what's returned to me, and then in the back, asynchronously, this thread is actually started and run. What's interesting now is we can do something called current thread. This is the procedure that takes in no arguments, and if I run it directly from my REPL session, it's running. That is running in the primordial thread. This is like the main thread. You'll also notice that I don't actually type a lot in my REPL window, so I don't actually do this. I don't type this out. I just move my cursor here and send it over these tiny things, and I really love being able to navigate like that. So let's run this now. So in a separate thread, you can see it returned, running thread start is returning me this. That's a thread that's returned to me. And that thread is then started and ran. And the current thread within that context is actually, obviously, unsurprisingly, thread 37. So current thread acts like parameter. It's called parameters in Scheme, and they're very useful. We're going to see them later on. So let's make an more interesting thread. Sleep 1. Top level function. I defined that earlier. Yeah, this isn't going to work. Testing. Now I can run it. Now I'm running it from the thread, and the thread is looping. So the thread is waiting for a second and it's running that function repeatedly. What I find really useful and very, very cool, hello world, is I can redefine this on the fly. So my thread is picking up this top level function only because it's top level. It would not do that otherwise. That's why I can mutate it. One problem with this is that actually if I start 2 of these threads, 3, 4, 5, 6, we've got this mess of threads and we can't really stop them. There is a way in Chicken to get hold of that. It's called sys_all_threads, I think. Like that. We could probably do some cleanup using that, but I'm not going to do that. I'm actually going to exit. And we're going to start it again. And zoom back in. And we're going to do define thread. If we add that now, sorry, forgot to define that. So now I've got this single thread that's doing what we want it to. It's called thread 37. So thread state of my thread. Thread is now a variable which I defined here, and it's the value of 37. The state of that thread is blocked. It's because while I'm running my REPL instance, that other thread isn't running, because they're never running simultaneously. Chicken doesn't have native threading support. It's just like Go. Actually, Go does that. Node, perhaps, or Ruby, and other languages. Cooperating threading, I think it's called. What we can do with this now, since we have a reference to it, we can thread terminate. It takes in a thread and it stops it. What's really cool is that if you structure this exactly this way, I do this sometimes, it terminates the previous thread and starts a new one. So if you want to change, for example, how frequently you want to sleep like this, without actually littering your REPL with several threads that you don't want, you can kill it like this, so that whenever it gets redefined, because remember, control meta X isn't doing the body definition, it's doing until it's not indented, so it's sending this entire thing. Control alt X sends me the entire thing, and that's very useful. So I do this quite a bit. So, Spiffy. Spiffy is a web server library for Chicken. It's probably, most definitely the one that's mostly used. Let's load it. Let's also terminate our thread because it's kind of annoying. Spiffy gives you a couple functions that we're going to look at now. Send response. You can't see now exactly the arguments, but you can see there's some there. It gives you start server. And it gives you vhost map. I know how to use these by heart, but I'm guessing that you don't, so let's look them up. You can go to api.call.org like this and have a look. So, start server isn't really anything to read about. It's a function that just starts the server. It does the TCP socket listening. What we're going to look at is vhost map. vhost map takes in a single argument, which is an A list of regular expressions to lambdas, or to procedures or handlers. If we access this directly, we can bypass spiffies like static file handling management and all these things, which is nice if you want to do REST servers or want to make something that you have where you have explicit control of what you're sending and what you're receiving. So the default is this. Let's modify that a little bit to app. So And start server simply just starts the server. There are no mandatory arguments there. We're going to start thread again. Wrap that in a lambda like that. Hopefully you get a feel for part as I'm doing this. Hopefully the ones that show up on the screen there are useful to you. So I think we're ready. We haven't defined app yet. Define app. Print called. App called. Define thread. Let's clean up this. So it should be running now. Let's check. So CZI is running on port 8080. If we actually call that though, it's going to hang. What's happening is that it's called my function, as you can see here. App is called, but nothing ever gets returned to the HTTP response. We're not actually sending a response. Let's do that now. Response body hello world. New line. So now I'm redefining app. App is now a new function which does make response, but it doesn't magically pick that up, obviously, since it's already inside the previous function, or it's actually exited. If we cancel this curl though and take the next one, now it's using the new function, and this is really neat and tidy, I think. Now I can do basically all my interactive development from here. I can change this and make this respond to me as I want. I can also, for example, I can current request. So now I'm redefining app so that it's going to set my top file R. It's currently unbound, but if I run this and try it again, now I get a request. Let's have a look at that request. Now I need interweb because I need to peek at the internal structures that spiffys are using. Request URI, for example. This procedure comes from interweb. So there are several things. R consists of several things. It has a port. It has a host, I think. Nope, does not. Let's look it up. Spiffy interweb request. So we've got request, major, minor. You'll notice the request prefix. These are basically just getters. So in object-oriented programs, you would do something like dot major or dot port. We can have a look at method just to try that. It should be a symbol get. Right, makes sense. No big surprise there. Parsers port. Let's have a look at the headers. There's another structure. URI is probably, or actually definitely the one that's most interesting. It's a little bit tricky though because we need URI common to be able to read the URI structure. So it's not pretty, but you get used to these things. URI path, for example, is going to pick out the path of the URI. So that's going to give us a list. If you recall, we did this. Hello world. Let's change it. So now, because I did set here, capital R gets the very latest one. So capital R is now the new one. If I do this again, it becomes hello world. It's a list where the first element is a symbol and the latter, and the remaining ones are strings of their directory entries. Unsurprisingly, there are several gotchas. For example, if we go here, localhost 8080 boo bar foo, and I do this, it's sending the response like before, just like we saw in curl, but you'll notice something different when I reevaluate this. The reason we're getting favicon.icon is because the browser is doing first the proper request, then it's doing the favicon request. So since in my code here it only saves the latter one, then it's kind of actually tricky to look at the request that the browser did. What we can do, for example, to fix that is say R1 for R. If we do that, we should be able to look at. So now R1 is not the latest one, it's the second latest one, and that's how we get that back if we want to look at it this way. All right, so this is how I like to work. I like to play with the runtime and during runtime, and then slowly converge my program into something that's deployable. Let's try and do that now. We can compile our program with Chicken and then run it as a standalone executable. It's pretty cool. Chicken compiles to C, so we can get native executables out of this. So in order for that to work, of course, we're going to need to do some cleanup, because our REPL here is some littering around. So maybe you're better using the REPL than me and don't produce that much litter, but these things you kind of learn. Let's try and run this. Okay, so we're here, and we've got our file. This is the same file. We can compile it with Chicken Scheme Compiler. What's cool now is that this creates a file that's executable, and it's linked against Chicken's runtime library, which again loads several more modules and eggs and things during runtime. All right, let's run it. Ooh, what happened? So our program immediately exits. The reason it does that is because what we're doing, we're creating a thread, and then at the end of the line, and the file there, there's an implicit exit there going on. So what we could do here is this. This would have the same effect. It would just run this in the primordial thread. But now it's no longer too friendly for a REPL if we want to mess around like we did before. So I'm going to undo that, and instead of doing that, what we're going to do is this. So a thread join, as you can see, takes in a thread, and it will just wait for that thread to exit. So thread join will block. That's essentially what we want. Let's try that now. So don't forget to recompile. Testing. Okay, so now it's doing something. Let's see if that actually works. Localhost 8080 hello world. Yay, it's working. And what's cool now is that if we have a look at which applications are running, we can see it's the application testing is listening on port 8080. So that's all I have. Thank you for watching. I hope you enjoyed. I hope you learned a couple tricks. See you next time.